Okay, so in working out molar volume, it means that we have to look at particular quantities. We need to get numbers around molar volumes. So that's the aim of the start of this. We've got a couple of mathematical questions to do here, but first of all we'll just do a quick intro to it. Okay, so what Avogadro figured out by experiment was, okay, he was able to measure a quantity of, say, hydrogen gas and a quantity the same, now exactly 100 centimeters cubed. This was measurable with measuring devices, and reacting the two volumes together, specifically known to be 100 cm cubed each, he discovered that after reaction there were no molecules left over. Okay, so no molecules are left over after reaction. So we're getting some idea then of this idea that the same number of molecules of hydrogen and chlorine must have been present in this reaction. So as well as having the same volumes of hydrogen and chlorine, we also have this idea that the same number of molecules of hydrogen and chlorine were also present. Otherwise there'd be some molecules that would be left over after reaction. Now, at standard temperature and pressure, the mole quantity, which is 6.022 as we know by 10 to the 23, has a volume of 22.4 litres, and this is confirmed with oxygen by experiment. So we do have an actual number, the mole number, the quantity that we've talked about before, and it's measurable by experiment that is 22.4 litres. Okay, so in this question here, I've done the example out over here. I've switched things around to make it just a little bit simpler. First thing I want to say though is just in this example up here, 450 centimeters cubed is equal to this amount over here, but you've got to delete the c out of this, otherwise your units are incorrect, because centi stands for 10 to the minus 2, and when you cube 10 to the minus 2 you get 10 to the minus 6. But that means you've accounted for the c then. So it means it's eliminated from over here. That's just all I wanted to say about that. In any case, over here you've got 22.4 litres is equal to 22,400 centimeters cubed, and that's just a conversion that you do for that. So also 22,400 centimeters cubed, as we know just prior to this, is equal to 1 mole. Okay, so if we do a divvy on the right hand side, if we divide across, we then have 1 centimeter cubed is equal to 1 over 22,400, and that's just by dividing this number from the left to the right. Okay, so that means now we've divided our number of moles, much smaller now because we've gone from 22,400 to 1 centimeter cubed. So 1 mole is going to decrease by a big amount, and this is the amount it decreases by. And then simply the question here that we're looking for is, we're looking for how many moles are there in 450 centimeters cubed. So what do we do then? We take our 1 centimeter cubed and we graduate it up to 450 centimeters cubed, which is going to be this figure from the previous line multiplied by 450, which turns out to be 0.02 moles. It's as simple as that. You just start off from the basics and work your way down. Start your question with the known amount for 1 mole to the amount that you actually are working with in the question, and then you get your final value out. 450 centimeters cubed is equal to 0.02 moles. Okay, next question then is to calculate the volume of 4.11 kgs of methane gas. I presume it's that STP. It's got to be when you're using the 22.4 litre factor. Okay, 4.11 kilograms, I've just worked it out over here, is 4.11 by 10 to the 3. Doing our unit analysis, the K is 10 to the 3 grams. So that turns out to be 4110 grams. Now, if you look at the molar mass of CH4 though, you see it's only 16.05 grams per mole. So it's a really small figure, whereas we have to quantify 4,110 grams. Okay, so that means that we're going to have quite a big volume. We're going to have more than 22.4 litres, if you know what I mean. So what we got to do is we have to find out how many of these there are in 4,110. So you do that division, and that's what's been done here, the smaller number into the larger number, and we end up getting the number of moles, which is 0.07 moles. We know that 1 mole is 22.4, but we're talking about 265.07 moles. So to work that out, we do a multiplication, and we end up getting this number here, 5736 liters, or 5.74 by 10 to the 3 liters, and that's your final answer right there. I think I see a little error here. I'm thinking the decimal point's in the wrong place, but in any case, that's our final answer. You just do a multiply up.